A 10-ton lorry. How on earth does the driver bring it to a halt with a single press of the pedal? Surely it's just a tiny bit of force from the foot. So why does it generate such immense braking power? In fact, the driver isn't pressing the brake itself, but rather harnessing the power of compressed air. This is the most common air brake system found on heavy goods vehicles. Many people think that the air brake is the brake itself, but that's not the case at all. The air brake is not directly responsible for friction braking. It merely controls and drives the braking mechanism. What actually brings the vehicle to a halt is the drum brake assembly inside the wheel. Inside the wheel, you can see two curved brake shoes, pressing tightly against a massive brake drum. When these two shoes are forced apart, they clamp down firmly against the inner wall of the brake drum, creating intense friction instantly. The rotation of the wheel is rapidly halted, and the entire vehicle begins to decelerate. What spreads these two brake shoes apart is a special S-shaped cam. When this cam rotates, the brake shoes on both sides are pushed open simultaneously, clamping tightly onto the brake drum. This cam, in turn, is connected to a sturdy metal pushrod. As long as the pushrod moves forward, the cam rotates, the brake shoes will open, and braking will occur, provided someone can apply sufficient force. To push this pushrod, the vehicle can generate extremely powerful braking force, and the air brake system is specifically designed to do this. The power source for the entire air brake system actually comes from an air compressor located next to the engine. This compressor is connected to the engine via a belt. Whenever the engine is running, it continuously draws in outside air. It then compresses the air to a very high pressure. This compressed air is fed into the vehicle's air reservoir for storage. However, during the compression process, the air often picks up water vapor, dust, and impurities. If these substances enter the braking system, the entire system could fail. Therefore, before the air enters the reservoir, it must pass through an air dryer. This completely thoroughly separated, ensuring the air entering the air tank remains dry, clean, and stable. In this way, the entire air brake system has a stable source of power. However, air cannot be compressed indefinitely. If the pressure continues to rise, the system will soon burst. Therefore, a pressure regulator must also be installed in the system to specifically control the air pressure. In the vast majority of lorries, the operating pressure of the air brake system is typically maintained between 0.6 MPa and 1.0 MPa. When the pressure in the air receiver rises to around 1.0 MPa, the diaphragm inside the regulator is pushed up by the air pressure, automatically closing the air inlet, causing the compressor to stop supplying air to the air receiver. When the pressure drops to around 0.6 MPa, the diaphragm returns to its original position. The air inlet reopens, and the compressor begins to recharge the air receiver. In this way, the entire system is constantly maintained within a stable and safe pressure range. Once the air storage system is ready, control is handed over to the driver's foot. Beneath the brake pedal in the cab lies a core component, the brake valve. When the driver presses the pedal pushes the piston inside the brake valve. The piston moves downwards, opening the air passage, allowing the compressed air in the air tank to begin flowing rapidly through the pipes. The lighter the pressure applied, the smaller the opening in the valve, and the less air flows through. The harder the pressure applied, the wider the opening, and the more forcefully the air flows. In other words, the driver is not pressing on brake pads, but precisely regulating the flow of high-pressure air. However, if all the air had to pass through the cab before reaching the rear of the vehicle, the dozens of meters of piping would slow down the braking response. To solve this problem, engineers designed a brake valve. When a braking signal is received, the brake valve does not allow the air to take the long way round, but instead opens a wide passage directly, releasing the high-pressure air from the air tank on the spot. A large volume of compressed air surges instantly into the brake chamber. Inside the brake chamber, there is a huge rubber diaphragm. When the high-pressure air rushes in, the diaphragm bulges instantly, generating a tremendous thrust. This force immediately pushes the push rod outwards. The push rod, in turn, rotates the S-shaped cam. The two brake shoes snap open and clamp down firmly on the brake drum. A lorry weighing dozens of tons is brought to a complete halt in a fraction of a second. When the driver releases the pedal, the air pressure in the system drops rapidly. At this point, an inconspicuous quick-release valve comes into play. It expels the air from the brake chamber directly to the outside, rather than slowly returning it to the piping. So the brakes release faster, and the response is more immediate. And precisely because the entire system relies on compressed air, before a heavy goods vehicle sets off, the driver usually starts the engine in advance to allow the compressor to gradually build up the pressure in the air tank to over 0.6 MPa. Only then is the entire air brake system truly ready for operation.